I'm Nick Altiero, and I'm the Dean of the School of Science and Engineering at Tulane University. After Hurricane Katrina, the university decided to take another look at itself and to take advantage of the opportunity of perhaps being able to define itself in new ways. And so the idea actually came from the president and the board, where they decided to put science and engineering under one roof and to assign us the duty of determining how to bring science and engineering together in a more integrated kind of an environment. And so that's what we've done. We've defined a school that has 6 divisions to it. There's a biological division, a chemical division, a physical division, an earth and ecological division, a mathematical division, and a behavioral division. And in each one of these divisions, we're bringing science and engineering together in both in academic programs as well as in research in the scholarly area. I'll give you an example. Let's take the biological division, for example. In the biological division, we've brought together cell and molecular biology and biomedical engineering. So we have degree programs in both, and we have very strong degree programs and research activities in both. But now we have the molecular biologists and the biomedical engineers working shoulder to shoulder. And so the basic science informs the practice, and the practice informs the basic science. And it just brings a whole new approach to science and engineering. It brings them much more in alignment with one another. The chemical division is another good example, where we've brought chemical and biomolecular engineering together with chemistry. And once again, the synergy there, both in terms of the curricular offerings as well as in terms of the research, has been very invigorating. We think more in terms of global change. We think more in terms of health-related issues, infectious diseases, this sort of thing. And so by having scientists, scientists of all types, and engineers of all types, working across these kinds of thematic areas, worrying about, say, infectious disease, worried about global change, it's a more integrated approach, and it's much more targeted toward solving problems than stovepipe disciplines. But we as a school have also partnered with the other schools on campus. We've partnered, in particular, we've built a very strong relationship with the School of Medicine and the School of Public Health and Tropical Medicine. Once again, to bring down the barriers, to bring science, engineering, and medicine, and public health closer together into a team, interdisciplinary type of an environment. I think the thing about Tulane that's relatively unique is that we are a Tier 1 research university among the top 100 research universities in the country, and yet we're small, and we're very much focused on undergraduate education. And that's pretty unique. And so what we've fostered here at Tulane, and in particular fostered in the School of Science and Engineering, is a very intensive research environment that cuts across disciplines, is at the forefront of discovery and innovation in all aspects of science and engineering. And yet, our undergraduate students participate in that in a very meaningful way. A very large percentage of our undergraduate students are involved in the research activities at the university. In fact, many of our majors actually require them to be involved. Take the issue of global change, and to hear how each one of our science and engineering disciplines views their role in meeting the challenges of global change, whether those have to do with changes to our ecosystem, whether it has to do with changes to our psychologically or behavioral system, what it has to do with energy, with the environment. Everybody has a different role to play in addressing these challenges. And I think that what comes across to the students is not only what the role of each individual science and engineering discipline is, but how we all come together to attack these problems as teams.